15th, 1947. Jackie Robinson walks onto Ebbets Field in Brooklyn, the only black player in an all-white league. The All-American game was sending a message to all of America. The status quo is going to change. Now, many of his teammates were opposed to it. He had to endure boos and catcalls from the crowd. Opposing pitchers would aim at his head. But one man went a different way. Pee Wee Reese, a white man from Kentucky, the shortstop, walked over and put his arm on Jackie's shoulder. The crowd fell silent. Years later, in 1997, Major League Baseball retired Jackie's number. Number 42 hangs in every major league park in recognition of his struggle to integrate baseball. Pee Wee's gesture helped us expand our understanding of race. If we could have looked at an individual's DNA back in 1947, I can bet you that almost everyone in that stadium would have assumed that Jackie Robinson's DNA looked quite different from Pee Wee Reese's, because look how different they are. Well, the technology does exist today. Are there biological differences between the races? What do you think? Well, let's have a look. For the last 200 years, people have tried to find a biological basis for race. Facial angles, skull size, eye shape, hair form, even brain color were scrutinized looking for some fundamental difference between the races. Well, throughout the last couple of centuries, people have used this sort of race science to justify things like genocide, slavery, and the European Holocaust. But now, at the beginning of the 21st century, we've been able to map the molecule of our genes. And it turns out we're way more alike than we are different. We members of the human race are 99.9% exactly the same. It's in our DNA. I'll prove it to you.
Now, you know where you're from.
That's right, Nye of Denmark. That's the Nyes. And here's my picture. We have a coat of arms from back in the day.
So that's one bit. What about the other bits?
Well, my grandmother is from France.
So, overall, you have any sense? Where do you think you're from?
Well, Europe.
Europe.
Yeah, Northern Europe.
So should we see if we can figure out where you're from on the basis of your DNA? You know real well on the basis of your history.
Well, that's only, though, a few hundred years.
Yeah, that's short.
So what we're doing is drawing some of my blood so we can get the DNA and sequence it. And we can compare those sequences to populations of people around the world and get an idea of where my ancestors came from. It's just nothing but fun.
Did you know that modern humans have gone through a mere 4,000 generations since they began emigrating from Africa?
Mr. Sanders, I read that because our species is so relatively young, humans are strikingly homogeneous, differing from each other only once in 1,000 subunits of the genome.
Mr. Sanders, what's a genome?
Well, Tommy, a genome is a gnome that has been surprised.
Are you sure, Mr. Sanders? That sounds kind of, well, stupid.
Genome is the DNA code that comprises the complete genetic composition of an organism.
Mr. Sanders, what's a...
Shut up, Tommy.
The dark continent. It's pretty bright out there. This is where we all came from. We're all Africans, genetically. Those were the days. Nina Jablonski is a paleoanthropologist. She studies ancient humans, our ancestors. Like most scientists, she subscribes to the theory that all humans, no matter where they live today, are of African descent. Until recently, scientists have had to rely on fossils and cultural artifacts to study human origins. But now, by studying DNA evidence, we have found genetic variation in human populations the world over. with the greatest genetic variation among people in Africa. So humans have probably been evolving there longer than anywhere else. By understanding the evolution and migration of human ancestors, we can also begin to understand the evolution of human skin color.
When we think about what our most ancient skin color was of the common ancestor of humans and our nearest ape relative, the chimpanzee, what we conclude is that actually our most ancient skin color was very pale, but covered with dark hair. But fairly soon in human evolution, around 2 million years ago, humans lost that chimp-like covering of hair when they became much taller in stature and became more active in open environments in equatorial Africa.
So you're saying being more active made you hotter?
Made you hotter.
So you lost your hair.
That's right. You needed to sweat effectively and you lost your hair. But as soon as you had a naked, sweating skin, you had to do something to protect it. And at that time, we theorized that humans became very darkly pigmented.
Based on DNA evidence, most scientists agree that humans started out here in Africa about 150,000 years ago. And people get restless. Maybe there were disputes, the neighbor kids playing their drums all night. Whatever. They started to move. And the first migration was about 80,000 years ago. There's about 4,000 generations. And people went this way. Here, Mesopotamia. People stayed here for a while, about 50,000 years. And then they started to spread all over Eurasia. And during one of the ice ages, people could make the leap across the Bering Strait and colonize the New World. Now, our ancestors back in Africa were clever. They were smart. The other animals in their ecosystem couldn't just change habitats, but the humans could. So in just a blink of an eye, in evolutionary terms, humans have colonized the whole world. Now, since we all have the same ancestors and we're all the same species, why do we look so different?
This is a map that shows the relationship between the known skin colors of indigenous peoples of the world relative to ultraviolet radiation. The most ancient human populations of the old world have very, very dark skin here at the equator.
Why would you ever lose your dark skin? You got dark skin, you're protected from the sun.
That's right.
So you go rambling, why would it ever change?
That's right. It's a great adaptation to high levels of sunlight because the melanin pigment is a natural sunscreen that protects your skin and other organs from damage. Ultraviolet radiation is mostly harmful to organisms on Earth, but it turns out that if you have skin that is too dark, you can't do something else very important in your skin.
And what's that?
Which is to produce vitamin D in the skin.
So the sunlight does something to chemicals that make us produce our own vitamin D.
That's right. When ultraviolet B radiation, relatively short wavelength radiation, impinges on the skin, it penetrates and produces the precursor of vitamin D, and then the final stage of conversion